Everyone. Hello everyone, welcome back to our channel Shivyogi Academy. Om Shri Guru Basavalingaya Namaha. In this video, you are going to deal with the study of electric power. Before watching this video, please do subscribe our channel Shivyogi Academy and share it out with your friends. Let's begin. Once again, welcome you all. Okay, electric power. Electric power, that is represented by letter P. Okay, electric power can be defined as, electric power may be defined as rate of doing work or rate of consumption of power or rate of dissipated power. When electric current flow through the circuit, it produces the heat. Obviously, there is a loss in the power. That is the consumption of the power. And SI unit of electric power is, that is P is watt. Okay. 1 watt of power is equal to the 1 watt of power is equal to the by 1 voltage of volt moving in a 1 coulomb of charge in a 1 second. Okay, 1 watt of power is equal to by a in a work done in a 1 second by a voltage of moving 1 volt in a, this is the material. Okay, the 1 watt that is nothing but a power in a 1 watt, that is equal to the work done in a 1 second by voltage of 1 volt moving in a 1 coulomb of charge in a 1 second, that is 1 volt into 1 coulomb divided by 1 second. So watt of power, that is P is the 1 watt of the power. P volt, as it is one thing, 1 is multiplied by anything, we get 1 volt, that much only, whatever we multiply by that. So V into 1 coulomb divided by 1 second, that is Q divided by T. Okay, that is represented by I. Okay, I is equal to Q divided by T. So V, as it is 1 coulomb divided by 1 second, that is 1 Q divided by 1 T, that is we got I. Okay, P is equal to V into I, watt, SI unit, that is watt. Other forms of the power is equal to P is equal to V is according to the Ohm's law, V is equal to I into R. Okay, use this circle, which term you want, circle it and read the remaining physical quantities. So V is equal to I into R. Substitute here, IR is replaced by V, IR, I as it is. So we got I into I square. So R, P is equal to I square into R. Another form of power is equal to, we can write like this also. So here I square, okay, use this circle according to Ohm's law. I circle this term, read the remaining terms, V divided by R. Okay, V divided by R. So place V divided by R in the place of I square. I is V divided by R. Already it is in square, whole square. R as it is. Okay, separate the terms. See, P is equal to V square. Apply square for individual terms, numerator and denominator. So we got V square divided by R square, and R is multiplied as it is. So P is equal to R and R get cancelled. Okay, so rest of the terms, V square divided by R, V square divided by R. Okay, so this is the one form of the power. And so R is equal to R is equal to V into I. Okay, V into I. P is equal to substitute in the place of R, or use substitute V in the place of IR. IR is substitute in the place of V. So we got V square, it is already. V is equal to I into R. So IR square divided by R. P is equal to I square R square divided by R. 1 R get cancelled. So P is equal to I square into R. Okay. P is equal to I square into R. Okay. The power is equal to, the forms of the power is equal to, formula we got, P is equal to I square into R and P is equal to V square by R. Okay. Next. The SI, we know that the SI unit of electric power is equal to watt. In practice, in actual practice, it is really small. The larger unit is 1 kilowatt. 1 kilowatt is equal to the 1000 watt. Okay, 1000 watt. The energy is, we know that energy is a product of power and the time. That's why it is used. It is commercial use is 1 kilowatt hour. The SI unit of power in commercial use, because watt is a very small in actual practice. That's why we use a larger power. Energy is equal to product of power and time. That's why time is in 4 hours. So H. So we can write 1 into kilo is nothing but a 10 to the power 3. That is 1000. Hour is equal to 3600. Okay, watt, because 1 minute is equal to 60 seconds. So 1 hour is equal to 60 minutes. 60 minutes into 60 seconds. So we got 3600 minutes equal to the 1 hour. So that. Okay. So multiply this 3, 6, 36 into 1, 36. Put 1, 2, 3, 4, 5 numbers of 0 after 36. So we got the result. Okay, easy method to multiply for the larger values. So 36,000 watt. So 1, 2, 3, 4, 5, 6. So we can write also like this 3.6 into 10 to the power 6 watt. Okay, or 3.6 mega watt. This is the commercial unit for the power. P is equal to 3.6 mega watts. Okay, I hope it's clear to all. Okay, once again recap this whatever we learned in the electricity. Electricity is nothing but a current flowing through a circuit. It creates a electric field, obviously. Okay, electric current is nothing but a rate of flow of electric charges with respect to the time. I is equal to Q by T. 1 ampere, SI unit of current is ampere. 1 ampere is equal to 1 coulomb of charge flow in a 1 second. So SI unit is equal to ampere. Very short units for ampere is equal to milliamp, microamps. Okay, next velocity, voltage difference in charges, that is the voltage. Imbalance of charges exists at the ends of the object or material or in a battery or in a cell, that is voltage. SI unit of voltage is equal to V, volt, short for V. Okay, resistance is nothing but it is one of the substance that is used to, it is opposes the flow of electric charges or electric current through the conductor. SI unit of resistance is equal to ohm. Okay, and all these three components, current, voltage and R, one and only one instrument is used to measure, that is the milliammeter. Milliammeter. Its name indicates that it is the measured physical quantity more than 1. Milli means multi. Multi physical quantity can be measured. How much current is exists, how much voltage is applied at the ends of the conductor, how much resistance is offered. So we can measure the milliammeter, and in specific current is used to measured by ammeter and voltage is used to measured by, that is one of the instrument to measure the how much voltage exists in the conductor, that is voltmeter, and resistance is equal to ohm meter. Okay, next is the which factors depends on the resistance, which factors depends okay on the conductor. Consider this the conductor. the factors which depends on the resistance, that is this is the conductor. Okay, length of the resistance is directly proportional to the length of the conductor. It depends on the length of the conductor. And cross sectional area of the conductor inversely proportional. How the area is increases, resistance decreases. Length of the conductor increases, resistance increases, and depends on the nature of the conductor and the depends on the temperature of the conductors. Okay, next. And how to remember the Ohm's law? Ohm's law. First statement, Ohm's law statement is when the current flowing through a conductor, okay, material current flowing through a conductor is directly proportional to the voltage exist in the conductor. Voltage exists in the, or voltage applied at the ends of the conductor, okay, and inversely proportional to the resistance of the conductor at a constant temperature. Okay, so I is directly proportional to V. I is equal to V by R. R is the proportionality constant or resistance of the material. V is the voltage in volt. I is the current flowing through the conductor. Okay, next, resistance. Resistor is known as is the one of the component which opposes the flow of electric current through them, and resistance is the property due to which, substance of the property due to which opposes the flow of electric current through them. So series circuit is nothing but components are connected in a end to end. Okay, more than one components are connected end to end, that is the series. In series there is only single path and same current flow through the circuit. When current flow through the circuit, it produces IR drops. IR is nothing but a V, no, according to Ohm's law. That's why voltage produces a drop in each circuit when current flow through the circuits. V1, V2, V3. Okay, V3. Okay, V is equal to applied voltage is equal to sum of the individual voltages or IR drops. So V3. So we got, according to Ohm's law, R is equal to total resistance in series circuit, R1 plus R2 plus R3. Suppose n number of resistance are connected in series, so we got the formula. So Rn minus 1 plus Rn. Okay, in this way we are going to find out the total resistance in the circuit. In parallel circuit, side by side connections. Okay, one end of the components are connected shorted together, and another end of the components are shorted together. That is said to be parallel circuit. In parallel circuit, many branches are there. That's why current is divided here, and the same voltage across the ends of the components where they are shorted together. Okay, so in I is equal to total current is equal to sum of the branch current is. So according to the Ohm's law, so 1 divided by R is equal to total resistance in parallel circuit, 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Suppose n number of resistance are connected in parallel, so we got 1 divided by Rn minus 1 plus 1 divided by Rn. Okay, in this way we are going to find out the total resistance. And if in a parallel circuit, if one branch is disconnected or break up, the remaining rest of the branches are working. Okay, doesn't depends on the another branches, because there are more than one path. Suppose one path is connected, the current flow through the circuit, but in series circuit, one component is disconnected or break down, the whole circuit will be doesn't work. Okay, off. So in next what it is in this chapter, heating effect of power. Heating effect of power, when current flow through the circuit, it produces the heat. Obviously power is consumed. Okay, heating effects of power that is represented by Joule's law. H is directly proportional to the square of the current, resistance of the conductor, and time. So H is equal to I square RT. One is the proportionality constant, one is multiplied by anything, we get that only. So Joule E. Next, the factors depends on the when heating effect produces about the conductor, that is depends on current, square of the current of the conductor, resistance of the resistor or conductor, and time. How long the current flows through, it power is heat is more heat generated. Okay, the many applications of heating effect are practical heating effects. Bulbs, electric bulb. Okay, see this bulb. Okay, it is the in a made by the tungsten wire. Okay, when current flow through the circuit, when we apply external source or switch on the circuit, the tungsten heat will be get rise the temperature. Okay, this bulb is inside nitrogen and nickel. Okay, nitrogen and nickel are the inactive, means inactive chemical, means when current heat is generated, there is no causes in the firing or etc. That's why it is the output is in the form of emits the light. Okay, that's one of the applications of the heating effect of electric current. Iron box and heater, toaster, so many applications are we see in our everyday life. One disadvantage of heating effect, when we are using mixer or a mobile charger, that get for taking the time as the passes, it generated the heat. So one disadvantage, it means that the resistance is decreases. Okay, in the given circuit, heating effects of electric circuit or heating effect of practical heating effects of circuit is equal to depends on the when the resistance increases, heating of the particular appliances are get higher, and when the current flow through the circuit is increases, then the temperature will rise up. As the time passes, temperature will be rise up. Okay, see some electrical symbols. Okay, this is the resistance. Okay, resistance. Okay, it is a fixed resistance, or 1 kilo ohm or 2 kilo ohm, 3 kilo ohm. How much it is manufactured, calibrated on that is the fixed. There is no variable. Okay, next this is the variable resistance, or we call the rheostat. Okay, how much we want to connect the circuit or construct the circuit, we can use that much only. Choosing is available here. There is no possible of choosing in the fixed resistance. Okay, next battery. This is symbol for the battery, positive terminal, negative terminal. Which one is larger than this? No, that is the positive terminal. This is the plug. Okay, this is the closed plug or key. Okay, this is the switch on. A, B is the terminals of the switch. If the switch is closed, that is the plug key is closed. Suppose open key, open plug key, that is a switch is open. Okay, next voltage also we can write like this, positive, negative. This is the voltmeter terminal. Okay, here always voltage connected in a circuit, that is parallel, and then this is the mini ammeter or ammeter, positive, negative. Ammeter always connected in a circuit in manner of series manner. Okay, next what we see, and this is the batteries, more than one battery is connected in the circuit. Okay, this is positive, negative. Okay, next this is the alternating current. Okay, this is the direct current, DC. These all are about the electric circuit. I hope clear to all, and prepare well, study well. Thank you. Once again, please do our subscribe our channel Shriyogi Academy. Thank you one and all.